Variables. Variables allow us to store single chunks of data. And sometimes when we are creating variables, sometimes you'll see them referred to as declaring a variable. So I have a couple of examples listed here. So it's important that we tell Java what type of data we're storing, and we have to give it a name. And so like for example here, we have int and age. We have string and first name. We have bool and breathing. So that'd be sort of a fun one to see if maybe you're playing a game and whether or not your character is breathing. A boolean is true or false. A string stores alphanumerics, and an int stores whole numbers. We'll get more into this in just a little bit. We can also create multiple variables at one time. So if you look here, we have string and then we have first name, last name. So we're creating two variables on one line of code. We can also do like multiple ones here for numbers. So here we have a data type called double, and we're creating the variable num1, num2, and answer. So we can create multiple variables at one time on one line, or we can create them one variable at a time. Variable names. Variable names have some very specific criteria on what we can actually name them. So first off, they can start with a letter, an underscore, or a dollar sign. Okay, but they cannot start with a number. Also, we do not want to put any spaces in our variable names. They have to be all together. All the variable names are case sensitive. So if you look down here at the example here, I have f name, and I have got it spelled out several different ways. And you notice here the first way is all lowercase. And then we have the one with the F is the capitalized, and then here the next one we have the N is capitalized, and then you can see the other two examples here. Java will treat all 5 of those as different variables. Okay, so it's case sensitive. As a matter of fact, all of Java is case sensitive. So you really have to watch your typing skills and make sure you watch your cap keys on that. Data types. Java has 8 primitive data types, and like I said before on here, we have to tell Java exactly what type of data we're dealing with. So we basically falls into a couple different categories. We've got 2 number categories, integer and real/floating, and then we have Boolean, chars, and strings. Okay, so let's talk about the numbers here. Integers are whole numbers, okay, no decimals. And then we have real and floating points. So they do have the decimal point. Okay. Now this is important for 2 reasons on that. First off, integers take smaller space and take less computing power than the real floating point. And then the second part of that is if we're dealing with math operations, okay, an integer math is different than real and floating point. So for instance, if I had 1 divided by 3 and it's integer math, okay, the answer would be 0. If we're using a real or floating point data type, then we would have the 0.33333 repeating. Okay, so it's real important to be cognizant of what type of data we're dealing with. Now let's just sort of look at here, and you can sort of see the chart here on what's happening here. So if we sort of look at our data and we say, hey, wait a minute, I'm going to have values that's going to be no larger than 32,767. Okay, so if I've got values that are going to be less within that range, then I can use the short data type. If I'm using a value here that's going to be greater than 32,000 and less than or equal to approximately 2 billion, then I'll probably want to use the int data type. Or if I got something greater than 2 billion, then we're probably going to need to use the long. Okay. Now if you look here, I have listed up on the chart here the different sizes, 8 bits, 16 bits, 32 bits, 64 bits. Okay, so a bit is a 1. So for a short, that's 16 ones and zeros. Okay, if we go down to an int, there's 32. So we see that that number is twice the size. And that's what gives us our max values for the different data types. Now if we look down in the real and floating points, so if we're dealing stuff with decimal points, then we have 2 options. We have the float and we have the double. So basically, if we're dealing with a number that's up to 3.4 times 10 to the 38th power, we can use a float. If we're going to do something even larger, okay, maybe we're working for something for NASA, and we'd have to have something really huge, on that, then we can use a double, and we're basically looking at 1.7 times 10 to the 308th power. That's 308 zeros, lots of places. I just want to point out too on here that if we're dealing with precise decimals, okay, like we're doing stuff with currency, or we're doing stuff with extremely accurate measurements on the decimal side of the house, on the right hand side of the decimal, then we want to use the Java math.big decimal library. Okay, so if we need to do precise decimals, we want to use the big decimal library, because that will take account of the rounding, and I'll make sure our rounding accuracy is very accurate. Now there's a couple other data types we need to deal with. Boolean. Okay, Boolean there is true and false. Okay, so we're checking whether something is true or false. Chars, these are individual letters or characters. And then we have string. Now string, it's treated like a primitive data type, but it's actually a class, meaning there's operations that can go with this. But for a string, at this moment in time, it can hold alphanumerics, and it can hold up to about 2 billion characters. So if you wanted to store one of the works of Shakespeare, you could do it in one string variable. Chars, one other note on that, they are usually width specific. So if we set up a char to only hold 2 characters, it will always hold 2 characters. Or if we tell a char to hold 10 characters, and we're only putting 5 characters in it, it will still hold the other 5 space on it. Where strings are variable, so it will only take up as much space as it needs. So those are the primitive data types in Java. Variable examples. I've listed here some examples here of how we declare variables in Java. And if we look up here, we have the one called int and age, and then we also have int age equals 0. So the int age equals 0, here we're setting that initial value to 0. We've got a couple here with the floats. We have a float in salary, and then we have one here where float salary equals 100,000. So in the second example of that one, we're actually setting the initial value to 100,000. Boolean, we can actually set that to true or false. Those are the only 2 values we can put in for that. Chars, we have an example of a char here for a middle initial. And I want to point out there that chars usually are enclosed by single quotes. And if we look down here at strings, strings are enclosed usually by double quotes. So if we are dealing with lots of words and text up here, we're going to use a string, and we're going to enclose those in a double quote. Constant variables. Constant variables are variables that we're going to set in which the values will not change. So there are times up here we want to set that variable value, and we don't want to have any other parts of the program to be able to change that value. And for example, that could be like pi 3.14 or a conversion factor. We don't want those to change. So in order to designate that, we're going to use the word final in front of our variable name. And the convention is to make that variable name in all caps. Constant examples. So here I've got a couple of constant examples to show you. If we look up here, we have final float pi equals 3.14. So the final is going to set the variable name. We have our data type float, and then we have our variable name pi, and then here's our initial value. We can look down here. We have another one here, final float H2O boil. So this is the boiling point of water, equal to 212. So final setting the value. We have our data type followed by our variable name in caps. Can you use other variable names in here besides float? You can. You can use any of the data types on there. You're just not limited to float. We're going to talk about enumeration a little later on here, but enumeration is using a variable name instead of a value. And for example, if we were coding a game in which north was 10 units north and south was 20 units and east was 30 units and west was 40 units, instead of thinking out, hey, which direction to go on this, we can actually do something like here, direction equals east. So that's sort of an example of using enumeration. We'll talk more about it later in the course, but here's how couple examples on how we can use the word final and lock in our values.